Alright guys, today I'm going to go over Firestarters 5, 6, 8, 9, and 10. So this video is going to kind of give you guys a whole bunch of those Firestarters. It's going to help you if you're struggling on your review worksheet. Remember, your review worksheet is coming up, so this is going to be very helpful with all of that. So remember, this is our hint page. You're going to have this on your quiz. Anytime you have any questions about that, that's going to be on your quiz. This would be the place to look. So remember, if you see the word simplify, if you know it's a simplify problem, that's when you're going to start with trying to break down the radical. So that, remember, I think the radical is a jail and stuff like that. If there's a radical in the bottom, that's when you're going to use our conjugates, right? Remember, conjugates can be easy or hard. Remember, I call those soulmates. Or you also have complex conjugates. That's like if I shows up, right? And then remember, we talked a little bit about the perfect squares. We talked about the imaginary number I, all that stuff. And this is if it's a solved problem. Right here is if it's a solved problem. Right. So if it's a solved problem, that's when you're going to use PEMDAS backwards. And then if the absolute value shows up, that's when you're going to use absolute value. So that's pretty much it for the hint page. If you have any questions, let me know. So Firestarter 5 is something when we talked about electricity. So basically, the easiest way to kind of think of that is resistance is what you see. So these ones right here, that's what you see. So you see this. Is what you see in the figure. So R is for the resistor, L is for the inductor, C is for the capacitor. All right. Impedance. This is what you're gonna write. So this is how you're gonna write it. What is a resistor? What is the value for the resistor? Or what is the resistance for the resistor in this problem? So a resistor is going to slow down current. All right, so basically this is being very, very simple. This is not the best way to explain it, or not exactly 100% accurate. But the best way to kind of think of it as a resistor is your source is providing power. Remember, with the alternating current source, that's why it goes back and forth. And we want to slow that down so we don't overload our circuit at any time. So a resistor will slow down the circuit flow to give it kind of time to get where it needs to be, and so we don't overload either our inductor or capacitor or the overall circuit. So a resistor slows down current flow. It's kind of the easiest way to look at it. All right. What is the value for the resistor? Well, in this problem, the value or the resistance, we're going to look here. We're going to look at the symbol. So this is our resistor right here. All right, and it's 5. So our resistor value R is 5, and this is called an ohm, right? That's the way you just measure resistance. It's a unit of measure for electricity. All right. So that's number 1. All right. So number 2. What is an inductor? Well, inductor, this is the squiggly, it's kind of a squiggly symbol, so this is our inductor right here. All right. So an inductor, remember, it is temporary storage. It opposes a change in the current. So basically, it's storing some of the current. Now, when we use our figure, right, the inductor right here. So the inductor, we're going to call it L. I don't know, I put I. I is not what I want. I want L. And it is going to be 3 ohms according to our figure. So that's the value or the reactance or the resistance of our inductor. Now, a capacitor is also temporary storage, but it's really temporary storage for the voltage. So inductors and capacitors are very similar in that they are temporary storage for energy, but one works with the current, the other one works with like the voltage or with the actual like power, the source. All right. In our figure, we're going to call the capacitor C. So I look here, and in this figure, it is 4 ohms. A circuit's total opposition, so total opposition of current flow is impedance. So that's the total. That's a big thing for us as we understand the word total. That means I'm going to do this piece plus this piece plus this piece. So I'm going to take each individual impedance. So here's what I'm going to do. I see R, so I see R, I see L, and I see C. I'm going to just change them into impedance. So impedance, look, here's the impedances. So to begin with, I see R, so I write R. So for my resistance, I write 5. Now, for L, I see L. I'm going to write 3I. That's all I do. Now for capacitor, I see 4. I'm going to make it a minus, and I write 4I. That's all I do. So the impedance, I'm going to add them all together. So I'm just going to, and really the only like terms I have are going to be the i's. So I'm just going to do 5 plus 3i minus 4i. So I end up with 5 minus I. So the whole impedance is going to be 5 minus I ohms. And that's it. 6 is going to be super, super easy now because I've already explained everything. I'm not going to write all these out. So remember, this is what I'm going to write, R, L, and C. So R in this figure is 9. I lied. Squiggly mark, right? So R in this figure is 12. L in this figure for inductor is 9 ohms. And capacitor C is equal to 7 ohms. Now remember, to get impedance, my total impedance is equal to, I'm going to put R plus, instead of L, I'm going to use Li. Instead of C, I'm going to do minus Ci. So all I'm going to do to get my total impedance, I'm going to do 12 plus 9I minus 7I. So my total impedance is equal to 12 is all by itself. 9I minus 7I is 2I ohms. That's what that symbol is. That's it for. That's all you have to do for 5 and 6. Now, 8. I have to remember that 1 is a simplified problem. This one is a FOIL problem because there is nothing going on between the parentheses. The second one, do not FOIL. Alright. So I'm going to FOIL the first one because there's nothing in between the parentheses. So I go 8 goes to 13. So 8 times 13 is 104. 8 goes to minus 6i. That's minus 48i. Now remember, I don't like to think FOIL. I like to think distributive property, where 8 is speed delivery guy. But either way works for me. So I'm going to go 8 times. Remember, so I'm just double checking my math. Yep, I was right here. Now negative 5i is speed delivery guy. Negative 5i goes to 13. Becomes minus 65i. Negative 5i goes to minus I, becomes plus 30i squared. Alright. Now remember, we learned that I squared turns into negative 1. So that makes this whole piece minus 30. So now I'm going to combine my like terms. 104 minus 30 is 74. minus 48i minus 65i is minus 113i. And that's it, done. Now this one, the negative sign is going to go to both because I'm going to subtract the negative 12, which makes it actually plus 12. I'm going to subtract the negative 4, which makes it positive 4i. So I'm subtracting both, that's why I have to change both signs. I didn't do anything in the first set of parentheses, that's why they stay the same. Now I just combine my like terms. Numbers with numbers, 15. Real imaginary friends with imaginary friends, minus 12 plus 4 is minus 8i. I am done. All right. Now 2, and I'm going to solve both of these. Remember, I'm going to use PEMDAS backwards, so if you're lost, I'm going to use PEMDAS backwards. So remember, it is PEMDAS backwards. That's if you're lost. Remember, this is if you're lost. It just tells you step by step what to do every single time. So since it's PEMDAS backwards, I see subtraction. So to get rid of that subtraction, I use addition. That's why I add 10 to both sides. So I end up with 6x squared equals negative 28. So subtraction's gone. I don't see any division. I see multiplication. That's why I divide both sides by 6. So some people think that it does take a little bit longer to kind of write it out this way, but it does keep me from making any mistakes. Now, negative 28 over 6 does not divide evenly. That is fine. I'm going to leave it as a fraction. When you simplify negative 28 over 6, it actually turns into negative 14 all over 3. Multiplication is gone. I'm going to see an exponent. How do I tell you to get rid of an exponent? I square root both sides. Now remember, whenever I see that negative sign inside the radical, I know it's going to leave the radical as a I. So this negative turned into that I. Now remember, I did square root both sides, so plus or minus has to show up. So I have x equals I, and I'm going to take the radical to the top and the bottom. Now remember, this is just doing what we did on our Firestarters beginning, where rule number 1 says you cannot have a radical in the bottom. So this is where my conjugate comes into play. So all I'm doing, I could stop here and be, 90% correct, 75% correct, but I do have to make the radical eat the bottom. So remember, that is an easy conjugate. So I pick radical 3 because that's his soulmate, and I put radical 3 on top as well. So now I end up with x equals plus or minus I 14 times 3 is going to be 42. 42. I'm sorry, 42. So I have the square root of 42 all over 3 because radical 3 times radical 3 is 3. Now I could I should. I'm going to double check and see if any of my perfect squares goes into 42. So 42 divided by 36 doesn't work. Divided by 25 doesn't work. Divided by 16 doesn't work. Divided by 9 doesn't work. Divided by 4 doesn't work. So that's it. There are no perfect square factors, so that is actually done. All right. Now remember, D, I see a bunch of mistakes here. Remember, I tell you to get rid of multiplication by division. So I do not want you to do this. Do not do this. No, don't do that. All right. You can't do that in this problem because the little 2 is blocking you. Plus, I tell you to get rid of multiplication by division. Do not do this. Right? Because I tell you to get rid of exponents by square roots, not by. So I look through my problem. The addition is actually in the parentheses. So the addition is actually in the parentheses. So there is not addition yet. There is no subtraction. No division. There's multiplication. That's why the first thing I had to do is divide both sides by 6. So now I end up with n plus 2 squared equals 50. Now what I'm going to go through, the addition is still in the parentheses. There is no multiplication. How do I get rid of an exponent? I square root both sides. So I end up with n equals, remember, because I square root both sides, plus or minus shows up. And I'm going to do a little multitasking. Remember, 25 is not perfect. And I totally messed up something here. N plus 2 equals, I'm going to do a little multitasking, 25 and 2 So remember, plus or minus shows up because I square root of both sides. This 25 turns into 5. This 2 stays in jail forever. And the last thing I do is I finally get rid of the 2. Now remember, because the plus or minus already showed up, the minus 2 goes in front of the plus or minus. So the best answer is minus 2 plus or minus 5 radical 2. And we are done. And that's it. Alright, so Firestarter 9, I think we did this in class, but very, very similar to everything we've been doing. 1, 2, and 3 are simplified problems, which means we're going to break down the radicals. So 12 is not perfect, but I have a perfect number 4 that goes into 12 evenly. So remember, I pretend that the radical is a jail, so to get out of jail you have to be perfect and you have to change. So 4 is going to change. He's perfect, he gets to leave jail, he turns into 2. 3, he's not allowed to leave jail, he's a murderer, he's stuck in jail forever. That's it. Number 2, I take the radical at the top and the radical at the bottom because I don't have any fractions on my perfect squares list. Now I know I need my conjugate box because I have a radical on the bottom. That is not allowed. So remember, I make the little box. This is a visual representation that whatever you put in that box has to equal 1. The bottom is an easy conjugate, so I make radical 3 show up because that's his soulmate, which means I make the top and bottom match. I multiply across the top, so I multiply across the top, I get radical 21. I multiply across the bottom, I get radical 9. So my best answer is 21 cannot be broken down. 9 can be broken down, so that's the best answer. Remember, 21 cannot be multiplied by or divided by 3 because 21 is in jail and 3 is not in jail. Alright, number 3, remember, I can multiply 5 and 10 together because they're both in jail, so it's the square root of 50. Now I'm going to go through, I'm going to break it down just like I've done before. 25 is perfect, 2 is not. 25 gets to leave jail, he turns into 5. 2 stays in jail forever, done. 4 is a FOIL problem because there's nothing in between, so I'm going to FOIL. 7 times 11 is 77. 7 times 6i is 42i. Now I'm going to do the inside. Negative 5i times 11 is minus 55i. Negative 5i times 6i is minus 30i squared. Now remember, since it's I squared is equal to negative 1, this becomes plus 30. Now I put my like terms together. 77 and 30 is 107. 42i minus 55i is minus 13i. That's my total problem. 5 is not a FOIL problem, but I do have to subtract both of them. So I have minus 21 because I'm subtracting the 21. Then I'm subtracting a negative, so it becomes plus 7i. I didn't do anything with the first part. So now it's real friends with real friends. 4 minus 21, negative 17. Imaginary friends with imaginary friends becomes minus 8i. That's it. Now 6 and 7 are solved problems. So if I'm lost, I put PEMDAS backwards. I see subtraction, that's why I add 7 to both sides. So I end up with 3x squared equals negative 24. Now I'm going to divide both sides by 3. Why am I dividing both sides by 3? Because I got rid of subtraction, there was no addition, there was no division, there's multiplication. All right? So I have x squared equals negative 8. Now I'm going to take the square root. Why do I take the square root? Well, because I got to get rid of an exponent. So I'm going to square root both sides. Remember, as soon as I square root both sides, I know plus or minus shows up. As soon as I see that negative in the radical, I know that I goes into the radical. So I have x equals plus or minus the square root of 8. 8 is 4 times 2. Remember, 4 is perfect, so this 4 leaves the jail and turns into 2. This 2 stays in jail forever. So that's your final answer. Remember, you could write it as x equals 2i radical 2 and x equals minus 2i radical 2, but you don't have to. Alright, 7, PEMDAS backwards, right? So I'm going to go through everything exactly the same. There is subtraction, but it's really parentheses. I don't see any addition, I don't see any division, I see multiplication, which is why I divide by 4. Most common mistake, I see somebody try to use the distributive property here. Do not use the distributive property here. Now, multiplication is gone, I got to get rid of an exponent. I square root both sides. Remember, plus or minus shows up whenever I square root both sides. So I have x minus 7 equals plus or minus the square root of 20. I'm going to do a little multitasking here. Remember, 4 times 5 is 20. 4 is perfect, 5 is not. I'm going to add 7 to both sides. So I end up with x equals 7 plus or minus. This 4 turns into this 2, and 5 stays in jail forever. And that's it. Firestarter 10, the exact same concept. 54 is not perfect. So I look at my list. I look for perfect numbers on my list that go into 54. 9 is the biggest one. It goes into it 6 times. So 9 gets to leave the jail. He turns into 3. 6 stays in jail forever. Done. As soon as I see number 2, I see radical on bottom. I change that equal sign to a multiplication sign because I'm going to make my conjugate box. Remember, it has to equal 1. This is a complex conjugate, so it becomes the bottom, or I mean, not a complex conjugate. It becomes a hard conjugate. So the bottom is you just change the sign in the middle. Now, whatever I put on the bottom, I put on the top. That's why they're the same. So I have 7, and in parentheses, I'm going to have 3 plus radical 5. On the bottom, I'm going to have 3 minus radical 5 next to 3 plus radical 5. So I'm just putting them together. This step is just kind of making it look better for us to understand how to multiply. So the top, I'm going to distribute. So 7 times 3 is 21. 7 and 5 cannot be multiplied together because one is in jail and one is out of jail. So it becomes 7 radical 5. I'm going to foil the bottom or your shortcut. There is a shortcut on your hint page for complex conjugates that says a plus radical b times a minus radical b is a squared minus b. So I take the first number, 3, I square it. I take the second number, 5, I just write it, and I put a minus sign in between. 9 minus 5 is 4. So the best answer becomes 21 plus 7 radical 5 all over 4. Now, if you look up the problem or something like that, the actual best answer would be if you split the fraction and they write it like this. Somebody's going to write it as 21 over 4 plus 7 radical 5 all over 4. To me, that doesn't bother me which way you write it. All right. 3. I'm going to take the guys who are out of jail and multiply them together. The guys who are in jail, multiply them together. This is not the only way to do this one, but it is one way to do it. So I'm going to do 15 times 8 to get 120. Now I'm going to divide. I'm going to find the biggest perfect number that goes into 120. It's 4. So this 4 gets to leave the jail and turns into 2. So I have 6 times 2 square root. This 30 stays in jail forever. So the best answer is going to be 12 radical 30. Four is not a FOIL problem because of the plus sign. So all I do is I put real friends with real friends, 7 and 11. Imaginary friends with imaginary friends, plus I. Done. 5 is a FOIL problem because there's nothing between parentheses, so I do 4 times 21, which is 84. 4 times minus 7i, which is minus 28i. Now I do the inside, minus 15i times 21, so I do minus 15 times 21, which is negative 315, and I add the I. Now I do minus 15i times minus 7, so I just do minus 15 times minus 7, becomes 105, and I make it I squared. Then I have to remember that I squared is negative 1, so that makes 105 minus 105. And I just do real friends with real friends. So I get 84 minus 105 is minus 21. Minus 28 minus 315 is minus 343i. That's the whole thing right there. Lastly, we're going to solve just like we've been doing the entire time. So now I'm just going to do PEMDAS backwards. Remember, if I'm lost, I would do PEMDAS backwards. So I see subtraction, that's why minus 10 from both sides. Subtraction's gone. I have 3x squared equals 60. No addition, no division, there's multiplication, that's why I divide by 3 on both sides. I end up with x squared equals 20. Multiplication's gone, there's an exponent, so I square root both sides. Remember, whenever you square root both sides, plus or minus shows up. I have x equals plus or minus the square root of 20. Now to finish the problem, you have to remember 20 is not perfect, but 4 times 5 is 20, and 4 is perfect. So that 4 gets to leave jail, he turns into 2. 5 stays in jail forever. And we can't forget about our plus or minus. 7, the exact same concept. PEMDAS backwards if I'm lost. There's no subtraction. There's addition, but really it's inside the parentheses. There's no division. There's multiplication. Remember, I tell you to get rid of multiplication by division. So I end up with x plus 7 squared equals negative 20. Multiplication's gone. There's an exponent. I tell you to get rid of the multiplication by, the exponent by square rooting both sides. So I get x plus 7 equals plus or minus the negative right here turns into I square root of 20. So I have x plus 7. Now I can finally get rid of the addition by subtraction. So my best answer is going to be x equals negative 7 plus or minus. Remember, 20 is not perfect, but 4 times 5 is 20. 4 gets to leave us 2, so it's 2i radical 5. And that's it. And that finishes Firestarters 5, 6, 8, 9, and 10. So I just got 5 Firestarters done for you.